Unit 2 Fuel, Numerical on Combustion, and some important steps to learn about this. Combustion is an exothermic chemical reaction in which the compound or element reacts with oxygen and release energy. Minimum or theoretical air or oxygen. What is it? This air or oxygen required by the fuel's component, carbon or fuel, is known as minimum or theoretical air or oxygen. This theoretical oxygen required by different fuels component is given. Carbon forms carbon dioxide, like that hydrogen forms H2O, sulfur forms sulfur dioxide, carbon monoxide forms carbon dioxide, methane forms carbon dioxide and water molecule. Ethene and ethine, they also form carbon dioxide and water molecule with different molar part. Second important point, that oxygen, nitrogen, carbon dioxide, sulfur dioxide, ash do not undergo combustion. Here it is important to note that oxygen assists in combustion reaction but itself does not undergo combustion. Composition of air is expressed by weight: nitrogen 77, oxygen 23. By volume, it is nitrogen 79 and oxygen 21. Fourth point is molecular weight of air 28.95 gram per mole. Fifth point, 1 meter cube is equal to 1000 liters. Sixth point is used to convert volume of air in terms of weight. So 1 meter cube is converted into weight, it is 1 kilogram, and 1 liter is equal to liter is related to gram. Meter cube is related with kilogram and liter is related with gram. Nitrogen is estimated from total air. Oxygen is estimated from excess air. Using Boyle's law and Charles' law, these laws can be used for reducing the volume at a given temperature and pressure to the corresponding volume at a specified condition of temperature and pressure using the simple equation P1 V1 upon T1 is equal to P2 V2 upon T2. Actual oxygen required is expressed by this expression: theoretical oxygen required minus oxygen present in fuel. It means that oxygen, if it is present in fuel's composition, it should be subtracted from theoretical air to get the actual oxygen required. In combustion calculation, always we use the concept of complete combustion. So theoretical or minimum oxygen is calculated on the basis of first point. In case of incomplete combustion, the product may contain carbon monoxide, but this concept will not be used in combustion calculation. Products of combustion are dry products or wet products. Dry products are carbon dioxide, nitrogen, sulfur dioxide, oxygen, but water vapor is not included. It is important to note that. But in wet products or products, carbon dioxide, nitrogen, sulfur dioxide, oxygen and water vapor or vapor is included in this calculation. It is important to note that. These are the steps to solve the numerical problems based on combustion. First of all, it is to be checked that fuel's weight or volume is given. Second step is to assume basis: 1 kilogram or 1 gram, by volume 1 meter cube or 1 liter. Write down the combustion reaction is the third step. And in fourth step, oxygen needed comes. By using these two formulas, air by weight is given by formula 100 upon 23 into weight of oxygen. That has come from the above oxygen needed value. Air by volume is given by formula 100 upon 21 into volume of oxygen. This volume of oxygen means oxygen needed that has come from the above calculation. Formula number 12 and 13 are the number of moles calculation when total volume of air is given or weight of air is given. In 14th point, conversion of volume to weight and vice versa is given. When air's weight is given, we can use this formula to convert air's into air's volume, like that. Sample problem. Now the whole numerical problem of combustion can be divided into 6 categories. In this presentation we will discuss category number 1, when fuel's composition is given in terms of volume and volume of oxygen or air is to be calculated. Carbon forms carbon dioxide, hydrogen forms water molecule. Sample problem is combustion of methane. Calculate air for combustion of methane by volume. So by volume is given. It means basis will be 1 meter cube or 1 liter. Volume of 1 methane reacts with 2 volume of oxygen to form 1 volume of carbon dioxide. It is depicted in the reaction. So 21 volume of oxygen is coming from 100 volume of air supply. So 1 volume of oxygen will come from 100 upon 21 volume of air. So 2 volume of oxygen will be coming from 2 into 100 upon 21. Numerical value is 9.52 volume, maybe meter cube or liter. This is the solved numerical problems. Find out the volume of air required for complete combustion of 40 liters of carbon monoxide measured at STP. Carbon monoxide's volume is given. Write down the combustion reaction for carbon monoxide. Here carbon monoxide, 1 mole of it requires half mole of oxygen. So 40 liters of carbon monoxide will require 40 into half, that is 20 liters. So minimum air required at STP will be volume of oxygen required into 100 upon 21. The numerical value is 95.238 liters. In the next lecture classes, we will discuss the other categories.